So, question is, what is really happening here? Why is the Earth's climate as stable as it really is? Okay, I will just now describe what I call my cloud thermostat mechanism and show that it's the dominant process controlling the Earth. It offers a very, very powerful feedback mechanism, and I'll show you how to calculate it. The great strength is occurring from these huge fluctuations that are observed in the power imbalance. Okay, how does it work? Well, clouds are effectively modulating the outgoing shortwave power, the outgoing reflected sunlight, and they control the Earth's, and there's at least 18 watts available, and it's actually much bigger than that, and much, much bigger than the claimed power imbalance. Okay, but remember that I mentioned that we seem to have a problem in calculating what is the actual total albedo of the Earth and what is the cloudy sky albedo. So they Wild et al. Think it is 0.36, although they never calculated it, but you just get that if you apply conservation of energy. So I will actually do the calculation both ways, where I'll say, all right, say they're right, say it's 0.36, or I'll also calculate it using a much more realistic number of about 0.8. The fluctuation of the clouds is measured by a very beautiful set of experiments by King et al. And now finally Stevens et al. Also shows you this non-periodic oscillation of the Earth's albedo. Okay, so this thermostat works just like the thermostat in your home. The power imbalance is never zero. Your furnace is always fully on or fully off. All that happens in what the thermostat does is it modulates, for various heat leaks coming in, changing, modulates the duty cycle of the power on. Rather underappreciated conspicuous properties of cloud. Okay, I already mentioned that it involves the dominant use of sunlight energy over the oceans is 73%. And we'll show you in a minute that it is by far the strongest feedback mechanism allowed. Okay, so let's look at a few pictures. Here's a few. You can go to NASA's website and get lots and lots of satellite pictures. One on the left was the astronauts' original Earthrise picture taken when they were first emerging from behind the moon. Okay, so here has a very low cloud cover. Various areas also have a very small cloud cover. Here's the Pacific Ocean, lots and lots of clouds. Here's over Australia. I've got a whole bunch of pictures of Africa showing huge variations just in the cloud cover. You notice that these clouds are bright white, okay, and that the cloud cover varies very strongly over the Earth. Clouds are clearly reflecting a lot more sunlight than the rest of the planet. Photos look like about 0.8 or 80%, 90% of the light. For comparison purposes, a sheet of white paper has a reflectivity of 0.99, and those are a lot closer to a sheet of white paper than the oceans are. Okay, the oceans are about, and land are about 0.16. They're browns and greens or dark blue. What Wild et al. Are saying is that the reflectivity of clouds is about equal to the average reflectivity of the whole Earth. That's clearly wrong just by looking at the pictures. Okay, what do we also know about clouds? they cast dark shadows. If you're in an airplane in a partly cloudy sky, and you look down on the ground, you can see the dark shadows below the clouds. Now, a lot of the illumination in the clouds is actually by the blue sky really scattering in between, so they're actually much darker than they look. Okay, or just driving along a mountain road and look down in the valley, and you can see the cloud shadows. They're really dark. Alternatively, if you have an ammeter on your solar panels, which I did when I was sailing to Hawaii, I was sitting there watching that, and found just even a simple solitary cloud passes over your solar panels, the output of the solar panel drops to 1/2 or less. Okay, worse yet. Say you're indoors on an overcast day. You're trying to read a book. You can't do it because it's just too dark. Where'd all that sunlight go that allowed you to read the book on a sunny day? It gets reflected back out into space. So, again, I mentioned, what did we notice from just looking at the AR6 power flow diagram? 70% falls on the oceans. The oceans are the big cloud factory. That's where all the water is, and 73% is used for making clouds and not for. Okay, now here's a very appreciated article by King et al. In 2013, and he separated out the Terra and Aqua satellite data into separate groups over ocean and over land. And what he measures, coverage area fraction. And the blue curve in the middle is the average of the two. Okay, so I have added on power scales, just like I did earlier. Okay, so multiplied by, say, our assumed solar constant, 340 watts, times the, well, I need to assume reflectivity of the clouds. So I used two choices. Assuming the cloud reflectivity is 0.36 and 0.8. I will point out that the IPCC reports totally don't even acknowledge the existence of this paper. Okay, so we have the left-hand curve. I'm assuming an all-sky albedo of 0.3, clear sky albedo of 0.16. That's what the IPCC uses. And so that gives you a 0.36 for the albedo of the clouds. Okay, so clouds that pass from ocean to land go from here to here. And those are the clouds that control most of the weather. At least they do in the North American continent. I'm assuming that's true elsewhere. I happen to live there, so I'm quite familiar with that. When they pass from the ocean to the land, that's the difference, and that's the change in the power. Okay, so here I'm using a more realistic measure of the cloud albedo of 0.8, and that gives that the fluctuation is the order of 55 watts per square meter. Remember, they claim that the IPCC in the bad penny is 0.6 watts per square meter. And if you add in the additional variation in the solar constant of about 22 watts, we're looking at 77 watts per square meter fluctuation in the power imbalance. Moreover, this is not slow. these two satellites pass over the equator an hour and a half apart. 3.5 hours apart. The dotted line here is from the Aqua satellite. That passes over at the equator at 1:30. Solid line is from the Terra, which passes over the equator at 10:30 in the morning. And so this is just in a matter of 3 hours, the change in cloud cover. This is presumably due to the fact that if you actually look at the cloud cover during the evening, it continuously builds on the oceans until about 3 or 4 5 in the morning. Okay. So remember those huge albedo fluctuations that Stevens et al. In 2015 noticed? They are clearly due to changes in the cloud variation. Okay, so how does it work? Remember, we got most of the power is being used for making clouds and for evaporating seawater. And the Earth has a very strongly varying cloud cover. The temperature control works exactly the same way as your home thermostat does. It corrects for temperature in the presence of varying modest heat leaks. For the presence of CO2 in the Earth's atmosphere, doesn't matter where it came from. It's actually a very small heat leak. We saw on some earlier satellites, it's only the order of 2 watts. It's what's supposed to do to CO2. There's never zero power imbalance. Okay, so how does it work? Okay, so when you have a high cloud cover, there are a lot of shadows on the ocean. The shadows, clouds are present. The shadows are essentially turning off the sunlight that's hitting the ocean. Clouds are not present, the furnace is fully on. So cloudy days are everywhere are generally cooler than sunny days. So when the cloud cover is too high, the furnace is off, the sea surface temperature is low, and remember we need sunlight to evaporate water. It's a very sensitive function of the air temperature. The evaporation rate is a very sensitive function of the air temperature over the water. We've killed the evaporation rate. So we had too many clouds. So quickly the cloud production rate drops, the cloud cover fraction drops, temperature increases, equilibrium is restored. The opposite happens when the cloud cover is too low. So, depending upon your assumption, we have at least anywhere from 18 to 55 watts available just to include a very wimpy heat leak. And no matter what, this is all trivial compared to the 2 watts maximum from CO2. Okay, let's look at the feedback strength. Okay, this was the IPCC's second important sacred measurement. So question is, why is the Earth just as temperature and climate as stable as it really is? So there are a variety of feedback mechanisms proposed, and there are a variety of analyses of these. One of the earlier ones is the National Academy, National Research Council report, Understanding Climate Change Feedbacks. There's a second one by Sherwood et al. Steve Koonin was the one who called this a very important paper to my attention. This is the so-called Ringsburg-Castle study. And then also by AR6 itself, pretty much chapter 7.4. So I have followed the methodology that Sherwood et al. Used, and I outlined that in Appendix C, available for questions period. They had a very restrictive assumption in there that they would not allow cloud fraction to be used as an intermediate variable. That's, from my opinion, that was totally silly, and why they never even noticed this. Sess et al., curiously, in 76 did use it, but that got forgotten. Okay, so you could evaluate again. I remember that I had two different possible cloud albedos, 0.36 and 0.8. So we have minus 5.7 is what I calculate. And for a more reasonable choice, minus 12.7. Values, the graph from IPCC's AR6, figure 7.1, and plotted those numbers on it. And in either scenario is by far the most powerful feedback mechanism. Here is from AR6. This is the cloud feedback strengths. Okay, this is a water vapor feedback, surface albedo. Here's what they claim for cloud feedbacks. They claim it's a positive destabilizing error. And so here is what they call Planck feedback. I assert that it's misnamed. It's really Stefan Boltzmann. Planck came along 21 years later, but somehow rebranding is in. Maybe he was racist. I know. Who knows why they renamed it? Anyway, so here's what they claim. It's the sigma t to the fourth. The fact that we have a fourth power for the power output just from the thermal heat is what does the stabilizing. Okay, so you take, and so I move that, and here's what I calculate here for clouds, negative feedback. This is for the 0.36. This is the IPCC's albedo. Here's what I calculate if I use a very reasonable sounding albedo. So, and if you take the sum of them all, it's clear down to here. So we're clearly moving a lot more powerful feedback. So what are my conclusions? Okay, so clearly this is the most powerful feedback mechanism. It's what is keeping the Earth's climate stable. Okay, it's used from minus 1 to minus 12, or minus 13. Okay, the size of this just, I think, confirms this is the dominant mechanism. And it gets its strength from the fact that we have these huge fluctuations. This is the power of how strong is your furnace. It's anywhere up to like 77 watts per square meter. Okay, so this is what people are spending trillions of dollars to do. They call it a solar radiation management system. I claim it already exists. It's built in. Nature has built it into it's our own cloud factory. It works very well. It stabilizes the Earth's temperature, and it's free. All of the IPCC's mechanisms cost trillions of dollars per year. So, what are my recommendations? Hey, if AR6 can give recommendations to policymakers, I will take that opportunity here. There is no climate crisis. There clearly is an energy crisis. We are a very serious energy crisis, and if we have to handicap ourselves by worrying about how we get our energy, this is very dangerous. Government is needlessly spending trillions of dollars to limit CO2 and methane. They are not pollutants. This very fact, the claiming they are pollutants, this went on under Lisa Jackson, who was President Obama's EPA director, claiming that getting them on, this was a power grab, because that put her in control of using the Clean Air Act and took it away from Steve Chu. Okay, so they're mandating trillions of dollars spent on this zero carbon policy. That, my recommendation, that is totally crazy and you should eliminate it. Trillions of dollars can be saved by limiting carbon caps, carbon credits, carbon sequestration, carbon footprints, zero carbon targets, carbon taxes, anti-carbon policies, fossil fuel limits in energy policy, okay? Subsidies on spin-off industries like electric vehicles, all-electric power, solar, wind should be eliminated. If they can't stand on their own economically, okay, I am not in the pocket of the oil industry or the coal industry, but fossil fuels are perfectly okay to use. Okay, so the IPCC has all these geoengineering projects. They're totally crazy. They're trying to do carbon capture, limit the CO2 levels. They're totally crazy and should be totally eliminated if they're there for doing global warming. Okay, so I end with Everett Dirksen's famous line in this 1969 regarding the simultaneous funding of the Vietnam War and Apollo programs. I will update it for inflation. $1 trillion here, $1 trillion there, and pretty soon you're talking about real money. Okay. Okay, for appendices, if you need them, if you get copies of the slides, here is this albedo theorem that shows that the total albedo is just the weighted sum of the individual area albedos. Okay, and there's a corollary. If you know the all-sky albedos, the cloud fraction, and the clear sky albedos, you can calculate the cloudy sky albedo, which is what I did to get the 0.36. So this is how you apply it to the data from the AR6 power balance. Okay, here is the feedback analysis that I can just pull this straight out of Sherwood et al., the Ringsford Castle study, and plug in. They assumed that they used the chain rule for calculating the effectively the various components of processes. They prohibit the use of, for some reason, they just simply prohibit the use of cloud cover area fraction as an intermediate variable in the chain calculus chain rule. Okay, so here's where if you plug in the numbers, it's just simply doing exactly what they do is modulates the shortwave downward power. So here's you calculate the final numbers to get the feedback strength. Okay, I'm open for questions now, assuming we have time. Thank you.